purpose of this video is to hopefully inspire you to learn how to use Mathcad. Mathcad can be used to do a lot of different things, but one thing it's particularly good at is solving systems of equations. And the equations don't have to be linear; they can be nonlinear. And so if you're solving something, for instance, like a 4-bar linkage, where you might have 9 equations and 9 unknowns, that's not the kind of thing you really want to do manually, especially if you're likely to make changes and then have to redo the calculation. So if you can just set it up in Mathcad, then you can just change the parameters and it will automatically regenerate new answers. So let's look at, just as an example, this problem. This is just a free body diagram of a robot trying to get up a ramp, and we have normal forces on the wheels. In this particular case, the rear wheels are driven, so there's some frictional force on that rear wheel, and we have the weight and location of the center of mass and also the wheelbase distance. And so all together we would have these 9 parameters if we include the coefficient of friction. And with Mathcad you would initially give it some values. And so in this particular problem we have 4 equations that would apply. Let me just try to refresh that. All right, so we have the 3 equations of equilibrium for this 2D free body diagram, and then we also have the relationship between the frictional force and the normal force down here on the rear wheel. So we have 4 equations and 9 parameters. So that means that we can set 5 parameters and then solve these equations to get the other 4. So in this particular problem, we want to find out what's the steepest angle we can climb, and that's where the coefficient of friction of 1, the weight is 25, wheelbase is 25. So we've set the coefficient here and the coordinates and the weight and the wheelbase. So those 5 things are set, and then n sub a, n sub b, the normal forces on the wheels and the frictional force and the angle we would then solve for. And you may realize that if you had like a point mass or a block, something like that, and you solve for the steepest angle given a coefficient of friction, it's just equal to, the angle is just equal to the arctangent of the coefficient of friction. So in the case of a coefficient of friction of 1, it should be 45 degrees. Yet here we're coming up with this, this 0.983 is in radians, that's 56 degrees. How is that possible? Well, if you look at the solution to this set of equations for this example, we get a negative normal force at B. Now if you had some kind of an amusement park ride with rollers on some kind of track or something where the force could be exerted down, that would be fine, right? So this would be a valid solution. But if you're trying to drive up a ramp, of course, the ramp isn't going to exert any force down on that wheel, so it's going to tip over before you get to this angle. So then if we want to solve this problem for, determine when is it going to tip over, it's not going to get to 56 degrees, so we could just change the normal force there to 0, and instead of solving for the n sub b, we would solve for the coefficient of friction. So now we get 0.588, which is 33.69 degrees. Okay, and the angle, the coefficient of friction is 0.667. So what does that mean? Well, that just means that that's the minimum coefficient of friction that you need in order to climb at this angle. Now, if you have a coefficient of 1, then obviously you can get to this angle, which would be this is the angle when the normal force on the front wheel is 0. So at this point with a coefficient of friction of 1, yeah, you can get to that angle, but if you go any steeper, it's going to tip over. Okay, so what about if the coefficient of friction is 0.5, less than that, right? And now if we come back to here, right, 0.405, and now we see that, and I'm actually going to have to stop here. So just finishing up with this introduction or promotion for Mathcad. We changed the coefficient of friction to 0.5, and now you can see that there is a positive normal force on the front wheel, N sub B. The maximum angle now is 23.205. So the point of all this, of course, is just to demonstrate that you can go back to these parameters and set any 5, right? Just set any 5 to what you want, and then solve for the other 4 very quickly down here. So if you had some fixed angle of a ramp you had to get up, and it was going to tip or whatever the issue might slip, you can try going with grippier wheels and plug the value in, change there, change the location of the center of mass, move the battery, and then quickly generate solutions. And so hopefully this gives you some idea of just the value of learning Mathcad.